two block system and friction. First, assume both the block as single block and find common acceleration. Assume both the block as single block, find common acceleration. Calculate the required value of frictional force. Calculate a required value of frictional force for common acceleration. So assume both the block as single block, find common acceleration, calculate the required value of friction for the common acceleration. Third point, if required friction is less than maximum friction or limiting friction, then no slipping. If F required is less than equals to F max, then no slipping. If F required is greater than F max, if F required is greater than F max, then slipping. So two block system in the friction, assume both the block as single block, find common acceleration, calculate the required value of friction for the common acceleration. If F required is less than equals to F max, then no slipping. If F required is greater than F max, then slipping occurs, and find different acceleration. So question is given to find the acceleration of the block and force of friction between them. Calculate acceleration of block and the force of friction between them. Calculate acceleration of the block and force of friction between them. First point is, according to the rule, find the consider both the block as single block, find the common acceleration. So common acceleration equals to net force divided by total mass. So net force divided by total mass. Net force equals to 50 divided by total mass equals to how much? 10 plus 5 equals to 15. So 5, 10, 50, 5, 3. So acceleration equals to 10 by 3 meter per second square. Common acceleration is 10 by 3 meter per second square. That is the common acceleration. Second, find the required value of friction on which force is not applied. Find the required value of friction on which force is not applied. Required value of friction is mass into acceleration. So mass into acceleration, mass of B into acceleration, that is 10 by 3. So that is 100 by 3 Newton. Third case, if F required is less than equals to F max, then no slipping. So find the F max value. Mu into n. Mu is 0.4 into n. N is m into g. 5 into 10. 4 into 5, that is 20 Newton. So maximum friction equals to how much? Maximum friction equals to 4 into 5, that is 20 Newton. That is the maximum friction. F required is 100 by 3. 100 by 3 approximately 33.3 is greater than 33.3 is greater than F max. F max is 20. As 33.3 is greater than 20, so both moves with different acceleration. So here F required is greater than F max, so both moves with different acceleration. Both moves with different acceleration. Then we have to find the different acceleration. So here applied force is 50, mass is 5. Frictional force equals to how much? Frictional force is mu into n. Mu into n, mu is 0.4. N is mg. Mg is 5 into 10. 5 into 10 is 50. So 4 into 5, that is 20 Newton. So acceleration of 5 equals to how much? Acceleration of 5 equals to 50 minus 20 divided by 5. So that is 30 divided by 5. So that is 6 meter per second square. That is the acceleration for 5 kg. So what will be the acceleration for 10 kg? Acceleration for 10 kg. So here the frictional force is 20. For 5 kg friction is 20. Every action has equal and opposite reaction. For 10 kg the friction is also frictional force is 20 Newton. So what will be the acceleration? Acceleration equals to 20 by 10. So this is 2 meter per second square. So that is the acceleration for 10 kg. That is 2 meter per second square. Given कि in the figure MA equals to 10 kg, question is given कि MA equals to how much? MA equals to 10 kg, MB equals to how much? MB equals to 15 kg. This data are given. Find the value of force for which block will move together. Find value of F such that both the block move together. Both the block move together. So first we have to draw the diagram. So diagram is given in the question. So this is the mass B. This is the mass B. Mass B is how much? Mass B is 15 kg. Mass B is 15 kg. Mass A equals to how much? Mass B is 15 kg. Mass A is how much? Mass A is 10 kg. So applied force is, this is the applied force. Applied force is F. F is the applied force. Mu equals to 0.25 given, and this surface is smooth. So mu equals to 0.25 and this surface is smooth. So find the value of F such that both the block move together. First procedure is to find the common acceleration. Find the common acceleration. Common acceleration equals to net force divided by net mass, that is 10 plus 15. So common acceleration equals to F divided by 10 plus 15, that is 25. That is the common acceleration. Common acceleration equals to F by 25 meter per second square. That is the common acceleration. Second is find the required value of friction on which force is not applied. So the required value of friction equals to mass of B into common acceleration. So this is the required value of friction. Mass of B equals to 15, common acceleration equals to F divided by 25. 5 3 15, 5 5s are 25. So this is 3F. So this is 3F divided by 5. So F required equals to how much? F required equals to 3F divided by 5. F required equals to how much? F required equals to 3F by 5 Newton. That is the required friction. So required friction equals to how much? Required friction equals to 3F by 5 Newton. That is the required friction. So that is the required friction. Mass of B into acceleration. F required equals to 3F by 5 Newton. Third bit, if F required is, so third bit is both moves with common acceleration. As both moves with common acceleration, question is given if F required is less than equals to F max, both moves with common acceleration. If F required is less than F max, both moves with common acceleration. Yeah, both moves together. So F required equals to how much? F required equals to 3F divided by 5 less than equals to F max. F max equals to how much? F max equals to mu into n. Mu into n. N is mg. Mg is 10 into g. G is 10. So 3F by 5 less than equals to mu is 0.25. 0.25 into 100. So this is F is less than equals to 25 into 5 divided by 3. So 25 into 5 divided by 3. So F is less than equals to 125 by 3 Newton. So F equals to how much? F is less than equals to 125 by 3 Newton. That is the applied force. So that applied force is 125 by 3 Newton.